Hi, today we're going to talk a little bit about congruency, and I will introduce you to the subject of congruency with shapes, but then what we're going to do is we're going to jump into congruent angles, and we're going to relate that to the other things that we've learned about lines and angles and supplementary angles and all of that good stuff. Congruency is pretty easy to understand, but it's pretty hard to understand just by listening to the definition of congruency. So I think it's easier if I show you what congruency is. And to do that, let's jump over to Microsoft Word real quick. Two shapes are congruent if they are exactly the same size and shape. Now, what I'm going to tell you is that both of these shapes, both of these rectangles, the blue one and the orange one, are both congruent to each other. That means that they are the exact same size and shape. Now, it can be difficult to sometimes see whether or not two shapes are congruent to each other, because two shapes can be in different locations. As you can see, the blue rectangle is in a different location than the orange rectangle. And they can also be rotated differently. For example, the orange rectangle up here in the top left is flat, but then in the bottom right corner, the blue rectangle is rotated at about 30 degrees. That doesn't mean that they're not congruent to each other. It just means that they're in different locations and they're rotated at different angles. And yet they are still the same size and they're still the same shape, that is, rectangles. The way that we can show two shapes are congruent is if we can rotate or move one shape directly on top of the second shape. So to prove to you that the blue rectangle is congruent to the orange rectangle, what I'm going to do is I'm going to move my blue rectangle up. I'm going to rotate it and move it over to the left and see if it can lie directly on top of the orange rectangle. So first, let's move our blue rectangle up. Okay, that's nice. It looks like it's about even with the orange rectangle. And now it's still skewed off to the side. So what I'm going to do is I'm going to rotate it and make it flat like the orange rectangle. And they look about the same now. But I need to move it over to the left. And now I'm almost there. And they're about parallel with each other. And I move it up a little bit more, and bam, they lie directly on top of each other. So we can say that even though we had to rotate the blue rectangle, and even though we had to move it a little bit, that they are still congruent. Because once I finished rotating and moving them, they were able to lie directly on top of each other. They had the same shape, and they had the same size. So for the generalized formal definition of congruency, we can say that two shapes are congruent if they can be turned, flipped, or moved directly on top of each other. Now, there are actually a wide variety of shapes that can be congruent to each other. And it's not just limited to shapes like rectangles and triangles and squares and circles and things of that nature. We can actually have two angles that are congruent to each other. And what that simply means is that we have two angles that have the same measure. For example, here I have drawn two angles. Here's one angle, and then here's my second angle. And notice that just like before, they're in different locations and they're kind of cockeyed a little bit from each other. This one right here is pretty much flat, whereas this one is facing up and to the right a little bit. But if this angle right here has a measure of 30 degrees, and if this angle right here has a measure of 30 degrees, it doesn't matter if this angle is located in the bottom right of the screen and this angle is located in the top left of the screen, they're still congruent to each other because they share the same measure. Now you might see the scenario with angles where one looks like it's bigger than the other. So I've kept my same angle that I had before right here that measured 30 degrees, and now I've added a new one that looks a little bit smaller that also measures 30 degrees. And you might be saying to yourself, well, I thought that if two shapes were going to be congruent, that they had to be the same size. And you're absolutely right. But remember that what these arrows mean right here on the edge of my angles are that it means that those lines extend forever and ever in that direction, and they extend forever and ever in that direction. And so really, even though it looks like these rays that make up my angle over here are smaller than the rays that make up my angle over here, they're really not, because they're both still going on and on forever in every direction. And so really I have two angles that are made up of rays which are infinitely long. So the next scenario that I'm going to introduce you to is a very common problem in geometry. So what we have here are two parallel lines. And what I mean by parallel is that I have two lines that are pointed in the exact same direction as the other line, and they're not on top of each other. And forever and ever, as these lines extend, they're never going to touch each other. Now let's say that before we had these two parallel lines, but all of a sudden we add a third line that is going to intersect the two parallel lines. It's going to cross both of them. Then we're going to have a whole bunch of different angles. We're going to create angles here, 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 and here, and angles here, 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 and here. Now, these angles have some very special properties. If you notice, what we have between this angle and this angle is a supplementary angle, because those two angles together create a straight angle of 180 degrees. So let's call this angle 1, and we'll call this angle 2. We'll call this angle we'll call this angle 3, and we'll call this angle 4. Well then, let's do a little bit of math. We know that the measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees. And we also know that the measure of angle 3 plus the measure of angle 4 is going to equal 180 degrees. But notice that between angle 2 and angle 4, they also create a straight angle. And angle 1 and angle 3 together also make a straight angle. So we can also say that the measure of angle 2 plus the measure of angle 4 equals 180 degrees, and the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Now if we can solve this first equation here in some way that can rewrite angle 2 differently, then we might be able to simplify some of these other equations down here. So what I'm going to do is I'm going to say that the measure of angle 2 equals 180 degrees minus the measure of angle 1. And what I can do is then substitute this value in to my third equation down. So what I'll get is going to be 180 degrees minus the measure of angle 1 plus the measure of angle 4 equals 180. And now, if I subtract 180 degrees from both sides of my equation, then I can see that my 180s are going to cancel. And I'm left with the measure of angle 1 plus the measure of angle 4 equals 0. And now I can add the measure of angle 1 to both sides. And I'm left with the measure of angle 4 equals the measure of angle 1. In other words, angles 1 and 4 are congruent to each other. They are the same. And the way that we say congruent is with this kind of weird equal sign symbol, but it has a little squiggly on top that's called a tilde. And so we can say that the measure of angles 1 and angles 4 are exactly the same. And likewise, if you do the math, try and solve this on your own, you can also see that angles 2 and angles 3 are the same. So angles 2 and 3 are congruent. So we can have a general rule that vertical angles are always going to be congruent to each other. Vertical angles are congruent. Now, let me give you a quick run through of the other angle relationships that have to do with our parallel lines here. Angle 4 and angle 6 are on opposite side of the line. So you can see that angle 4 starts on the left side of the line and then it flip-flops over to the right side of the line. So they alternate. And likewise, both of them are on the inside of the two parallel lines rather than the outside. So we can also say that these two lines are interior to the parallel lines. And thus the name for these two angles is alternate interior angles. And they are congruent to each other. In other words, angle 4 is congruent to angle 6. And likewise, there's another set of alternate interior angles on here. Let me see if you can find them. Pause the video real quick and see if you can pick them out. Okay, so the other alternate interior angles in this diagram are angle 5 and angle 3. They alternate. Angle 5 is on the left and angle 3 is on the right, but then they're also on the inside of these two lines. So they are alternate interior angles. Now what this means is that if angle 4 measures 30 degrees, now what this means is that if angle 4 measures 30 degrees, then angle 6 has got to measure 30 degrees. And likewise, if angle 3 measures 120 degrees, then we know without having to do any other math that angle 5 is going to measure 120 degrees as well. As you can see, the usefulness of this theorem is that I can instantly know what the measure of some angle is in a completely different portion of our diagram without having to do any extra complicated steps. So let's do a quick practice problem. Let's say that I know this angle right here has a measure of 150 degrees. What I want you to do for me is find out what the measure of angle 6 is. So find the measure of angle 6. Pause the video real quick and see if you can figure that out. Okay, so we know that this angle right here is 150 degrees. And this angle right here has an alternate interior angle over here. So we know that since alternate interior angles have the same measure, that this angle right here also has to be 150 degrees. And notice that this angle and angle 6 create a straight angle. So what we can say is that 150 degrees plus the measure of angle 6 is equal to 180 degrees. And if I subtract 150 from both sides, then on the left, my 150s are going to cancel. And if I subtract 150 over here, then I'm going to be left with measure of angle 6 equals 30 degrees. And so we know that this is going to be 30 degrees right here. One thing I want to draw your attention to is that if you notice, 150 degrees plus 30 degrees is equal to 180 degrees, which is pretty nice. And in case you forgot, whenever we have two angles that add to be 180 degrees together, they are supplementary. So what we can say is that anytime we have interior angles, that means that they're in between the two parallel lines. And they're on the same side of their intersecting line, which means that they're both either to the right or they're both to the left. If they're on the same side and they're interior, like this angle right here and this angle, then we know they're going to be supplementary and they're going to add up to 180 degrees. Now the next angle relationship that I want to talk about are these two angles right here, angle 1 and angle 7. Now previously we said that angles 3 and 5 were alternate interior angles. Can you guess what angles 7 and 1 are going to be called? Well, they alternate again, right? Because angle 7 is on the right side and angle 1 is on the left side. So we know that they're going to be alternate. But instead of being interior angles, which would imply that they would be between our two parallel lines, they are outside of the parallel lines, which means that they are alternate exterior angles. What this means is that if angle 1 has a measure of 110 degrees, then we instantly know that angle 7 is also going to have a measure of 110 degrees. Now see if you can find the other alternate exterior angles on this diagram. Pause the video real quick and see if you can figure it out. Okay, so the other alternate exterior angles in this diagram are going to be angle 2, which is right here, and angle 8, which is right here. they alternate. Angle 2 is on the right, angle 8 is on the left, and they're both outside of the parallel lines. So that means that they are exterior angles. And likewise, notice that angle 8 and angle 7 together are going to create a straight angle between the two of them. So we can say that angle 7 plus angle 8 equal 180 degrees together. And so if I substitute in 110 degrees for angle 7, then I get 110 degrees plus angle 8 equals 180 degrees. And if I subtract 110 from both sides, then my 110s are going to cancel and I'll get angle 8 equals 70 degrees. And interestingly, just like before, where angles 3 and 6 were supplementary, you can see that if angle 8 is equal to 70 degrees, that 70 degrees plus 110 degrees is going to be 180 degrees. So we can say that angle 8 and angle 1 are supplementary. And likewise, we can also say the same thing about angle 2 and angle 7. They are also going to be supplementary. So the last thing that I want you guys to do is we're going to do a quick review, okay? Because we've covered a lot of angle theorems and I want to just go over all of them real quick at one time. So what I want you to do real quick is I want you to pause the video and I want you to label all congruent angles on this diagram. Okay, so the first thing that I'm going to look for are our alternate exterior angles. And that would be angle 1 and angle 7. We can say that angles 1 and 7 are congruent to each other. And we also know that angles 2 and 8 are congruent to each other. So we can also say 2 is congruent to 8. Now what we need to do is we need to find all alternate interior angles. So 6 and 4 are alternate interior angles. So I can say that 4 is congruent to 6. And likewise 3 and 5 are alternate interior angles. So I can say that angle 3 is congruent to angle 5. Nice job. Now the last thing that I want you to do is to pause the video real quick and label all supplementary angles. Okay, so the first thing that we're going to do when we're looking for supplementary angles is we're going to be looking for angles on the same side of the transverse line. The transverse line, just to review with you guys, is the line that cuts across my two parallel lines. So I'm looking for angles that are either both on the right or both on the left of this line. So I know that angle 2 and angle 7 are both on the right side of this line, and they're both exterior angles. So those two are going to be supplementary. We can say that angle 2 is supplementary to angle 7. Now, likewise, angle 1 and angle 8 are on the left side of my transverse line. So I can say that angle 1 is supplementary to angle 8. Now let's go for interior angles. I can say that angle 6 and angle 3 are both to the right of our transverse line. And they're both interior angles, so I can say that angle 3 is supplementary to angle 6. And finally, angles 4 and 5 are both to the left of my transverse line. So I can say that angle 4 is supplementary to angle 5. Okay, so that's enough for today. Tune into the next video and we're going to do some practice problems from the Regents on lines and angles and the types of problems that you'll see on the Regents that will cover the material that we've gone over so far.